Hello. So, in this lecture we will talk about multiple topics including perfect forward secrecy, lifetime and rekeying in IKEv version 2. A difference between IKEv version 1 and IKEv version 2 is that in IKEv version 1, SA lifetimes were negotiated and had to match. This is not the case in IKEv version 2, which alleviates lots of headaches that plagued version 1. Each end of the security association is responsible for enforcing its own lifetime policy. So, the lifetime is locally significant and is not communicated with the other side. Also, there are multiple timers applicable to IKEv version 2. You have the rekey lifetime, the IKEv lifetime, as well as the reauthentication lifetime. They are locally significant so that there are no issues with lifetimes matching between the two IKEv peers like version 1 did. So, the IKEv SA lifetime means the IKEv session life expires after X number of minutes or hours. That means, there will be a new IKEv SA init and authentication messages between the initiator and the responder. This will result in the old IKEv SPIs expiring and would get replaced with new IKEv SPIs for initiator and responder. Now the next concept is reauthentication timers. This is used to ensure that the other party has the updated credentials. With reauthentication timers, the two sides authenticate each other again. So, there is no mechanism to maintain the same IKEv session with reauthentication. The reauthentication basically results in creating new IKEv session, new IKEv SPIs, and child SAs. So this is easy to understand. The outcome is the same, however, new IKEv SPI initiator and responder gets created, new Diffie-Hellman exchange and new ASP, SPIs. So here we see two ISPIs, initiator and responder, message pair 1 and message pair 2. So of course the two lifetimes can clash, meaning that if you set the IKEv lifetime shorter than the reauth timer will never trigger. It doesn't make sense to set the reauth lifetime shorter than key lifetime, as every time the IKEv lifetime counter resets, the reauth timer will reset as well. So, reauth makes sense if you make it much higher than lifetime. This way it will force reauth after a longer period of time. Now, the rekey lifetime is different. The rekey lifetime will result in new encryption and authentication keys as well as new ASP inbound and outbound SPIs to be used for traffic encryption. Okay, so let's assume that the initiator is locally configured for a lifetime of 1 hour. After 1 hour, the initiator will send an IKEv message of create child SA with new nonce initiator and nonce responder. It will generate new set of keys for the traffic. However, there is one caveat here. It will reuse the S key ID, D. So, even though new keys were created, those are just for the phase 2 piece, or we should not call it that as IKEv2 doesn't have the concept of phase 2. It will create new child SA, however, using the same S key D. So the rekey lifetime refreshes the keys for the traffic encryption. So, if we see here, we have a single pair of IKEv SPI initiator and IKEv SPI responder under which two phase 2 SAs were created. One generated messages ASP 1 and 2 while the other generated messages 3 and 4. Okay, now we come to the topic of PFS. So, when you do the rekey, a new create child SA request gets initiated to basically rekey the ASP, SPIs. This request response has new nonce initiator and nonce responder for that exchange. So, when this gets negotiated, a new key mat gets created. This uses the same S key, D. The only difference is that the nonce initiator and responder are different, which would result in generating new keys. As we see here, the create child SA that resulted in new keys set of S key encryption and integrity 2 for initiator and responder used the same S key D in its operation. So, when this happens, the IKEv SPIs doesn't change, it will be carried over, just new ASP, SPIs. Finally, we come to the topic of perfect forward secrecy. In this case, whenever a create child essay is issued, there is a new Diffie-Hellman exchange and new Diffie-Hellman master key. This is indicated here by G exponent of I and R. So, something to be very clear about, and it trips a lot of people. You could have two IKEs, one configured with ASP to do PFS and the other with no PFS. It will work just fine. You know why? Because the first child essay uses the same sets of keys generated in the IKEv2 messages. If one side is set with PFS, they will start communicating fine, but when it comes time to rekey, or create a child essay, the issue will be that the other side is not set to PFS, so they wouldn't be able to renew the keys. Hopefully this was helpful. We will discuss more in the next lecture.